So, like I said, today is our start of our unit on systems of quadratic and linear. Now, your second unit that you guys did was systems as well, but it was systems of what equations? Just linear. So, when you have a system of linear equations, it looks something like this, right? And what would the solution to that system be? Where they intersect. Good. Now, not only does it have one number in the solution, it has how many? Why 2? It's a point. The intersection is a point, an xy point. When we have a quadratic, however, a quadratic with a linear, how many solutions could we end up with? 2. That means we're going to have how many points? 2 points. XY, XY. However, are all systems going to look like this? What else could it look like? It could, but this is the unit purely on quadratics and linears, okay?
Couldn't the linear be like steeper so it only goes through one?
Yes, very good. We could have a quadratic with a linear that is tangent to it, meaning it only touches it in one spot, like that. I don't know why I keep saying shift. You see that? Okay, so this is only one solution. What else could we end up with? So, yes, you're right, but this is the unit just purely on quadratics and linears. Just one quadratic and one linear. A system of those two. So we have 2 solutions, 1 solution. Oh my gosh, no solution. What do you think that's going to look like? A quadratic with a linear where they never touch. This is no solution. You will actually, when solving this, end up with an imaginary solution for x, but we won't make you finish the problem. We'll just ask for you to say no solution. That's a pre-cal T. That's what you'll do in pre-cal, is to finish that. But here in Algebra 2, you can just say no solution. Yes?
Do you want us to write this?
No. No. Thank you. All right, so let's go ahead and start our notes. Where are they? There they are. Okay. So on the first tab, the graph flap, we have a system of a quadratic equation and a linear. How many solutions did we have here?
2.
Where are they? What are the solutions? -3, 0, and 5, 8. Exactly. Now, when you're solving a system algebraically, not looking at a graph, clearly here it's easy to find the solutions. You just look at the graph and boom, you have your solutions. When we're solving algebraically, your equations need to be in a specific form. What form do you think the linear equation needs to be in? Y equals mx plus b, our slope-intercept form, right? Y equals mx plus b. Want to take a guess at which form the quadratic needs to be in? Standard. Last class, everyone said vertex first, but yes, it needs to be in standard form, and you'll see why in a minute. It needs to be in standard form. And like we were saying before, your solution needs an x and a y value. It's a coordinate point. The hardest part, honestly, the hardest part about this unit is that a lot of you guys are going to forget to also solve for the y. You'll stop at x because that's where we normally stop and say, oh, I'm good. But you have to remember, no, a system means that there is an x and a y value. All right. So over here, I have so nicely, because I know a lot of you are step-oriented, I have so nicely outlined these steps to solving a solution. So first step, put each equation in slope-intercept in standard form. Now, all of this means is get each equation to be y equals. So get the y all by itself. Get the y all by itself. Let me zoom in there. Step 2, use the substitution method to plug one equation into the other. So if both equations are y equals, what do you think this means? Oh my gosh. All that this means is set the equations equal to each other. Set the equations equal. Then set your equation equal to 0. This just means get everything to one side. Get everything to one side. And then lastly, solve the, not lastly. Step 4, solve the quadratic to find your x value. Now, how last unit did we solve quadratics? One of the ways is quadratic formula. Is that the way that you should try first? Probably factoring. So one of the ways is factoring. Then what? If it doesn't factor? Quadratic formula. Are there other little ways, little tiny ways that you use every once in a while? Yeah, like difference of squares, square root method. But mainly for systems, you guys are going to be doing either factoring or quadratic formula. And then, of course, because now that we have an x solution, we need to take that x and plug it back into one of the equations, usually the easier one, to find the y, to get your coordinate point. All right, so let's try it. I know for some reason the examples didn't print. So example 1 right here is, no, is, should I make it a little bit tougher? Yeah. All right, there are 2 equations. Whoa. So can you take a guess at how I made these a little bit trickier? I put them not in standard and slope-intercept form. So our step 1 tells us to do what? Get y by itself. So how can I get this? And I'll number them so that we can be nice and organized and keep track of our equations. How can I get equation 1 to have y all by itself? Divide by negative. I know you guys have been taught over and over again to get rid of, or how you should think about it, to get rid of the negative, you divide by -1. In my head, I know, okay, so if I want to change the sign of the y, I need to change the sign of everything. So I just make y positive, make 2x positive, and make 2 positive. So it becomes y equals 2x plus 2. Of course, you can just think of it as dividing by -1. And then equation number 2. What do we do to get that all by itself? That y. Yes. Move x squared to the other side by subtracting x squared. So it's y equals -x squared plus 5. Now that I have the y's all by themselves, what is my next step? Use substitution, or you can just think of it as Setting them equal to each other. Now that we have them both to be y equals, they're both equal to the same thing, right? They're both equal to y. We want to know where they intersect. It's going to have the same y value. We can just set them equal. So what color should I use? Yellow? So I'm going to have 2x plus 2 equals negative x squared plus 5. Now, my next step is to get everything over to one side, right? This entire equation is now a what type of equation? I hear people whispering it, but they don't want to be wrong. It's a quadratic. How do we solve quadratics? Factoring or quadratic formula. Both of those need to have everything what? On the same side of the equal sign. So, which way should I move everything? Y to the left. My life becomes a lot easier when my a value is a positive 1, right? So if I move that negative x squared to the other side, it becomes a positive x squared, making my life easier. And I have to remember to subtract that 5. So I have x squared plus 2x minus 3 equals 0. Now, what should I check for first before doing anything? Greatest common factor, yes. I check for a GCF. Is there a GCF here? No. Now what do I try first? Factoring. Try factoring first. What goes on top of our x? Negative 3, a times c, and what goes in the bottom? And what do I ask myself? Yes, what multiplies to be negative 3 but adds to be 2? So what two numbers multiply to be negative 3 but add to be 2? Ah, yes, 3 and negative 1. Whoops. Are these the numbers that indicate my real factors, my true factors? Why yes? I have no a value. So these are not my false factors. So I can just bring them down and boom, I have my factors. Do I just want factors? Is that where I stop? What am I looking for? Solutions. So I need to have x equals. How do I find the solutions for these two factors? You set them equal to 0. So x plus 3 equals 0 and x minus 1 equals 0. And then you just get x by itself to get your solutions. X equals negative 3 and x equals 1. Are you done?
No.
Why are you not done? You must get your y's as well. These are coordinate points. So I know you're running out of room on yours. I have the ability to zoom in, so it's nice. So I would solve for your y's up here, if you haven't gone over there already. Solve for y now. How do you solve for y? Plug in x. Which one do you want me to plug in x to? Yes, I would probably, most always, plug y into your linear equation. Now, does it matter whether you plug it into the original versus the slope-intercept form? Are these still the exact same equation? They are. So does it matter? No. So I would plug it into the slope-intercept form, making my life easier. Y equals 2. Should I put an x there? What should I put? Negative 3. And what is 2 times negative 3? Negative 6 plus 2. And then for my second equation, what do I plug in this time? A positive 1. What is 2 times 1? Plus 2. So, should I leave everything just like this? Oh, I'm sorry, it's hard for you to see, really. Can you still see your papers? Should I leave everything like this? How should I finish this up? Wrap it up nice. Write it in coordinate points. Yes, that's what we were trying to find. So what are my coordinate points? Negative 3, negative 4, and 1, 4. Have you ever seen coordinate points in a solution set? In the squiggly brackets? No, it's not a thing. You can just write your coordinate points and circle them. All right, example 2. I am going to have you start, if not finish, example 2, which is 4x equals 2y plus 4, and negative 5 equals negative y minus x squared. This is your example 2. I want you to start it. Get as far as you can. Keep in mind, I'm going to go over it after you're done, but I will be extremely impressed if someone in here can get the full and final answer here. So try to impress me. We'll spend about maybe 6 minutes on this problem.